we're going to ask them to introduce their company and then we will go and get some vision for what we look like in the next 5 or 6 years. And then open it up for your questions. So we have 3 panel members. George Peng is with Tempo Automation. George. Ruben Villarreal from Flex, and Uwe Schulze of Zollner. So who would like to go first? So what I'd like, so we got this beautiful dragon up here. So Uwe, will you start?
Yep. So you're welcome here in Fremont. I want to introduce as first our company, or my company, Zollner Electronics. We are a family-owned company in the Bavarian Forest in Germany, and we are the biggest one and biggest EMS provider in Europe, and we are also part of the 15 largest one worldwide. And we have 18 sites worldwide, especially 2 here in the Silicon Valley, 1 in Milpitas and 1 in Fremont. And I will not bore you with a lot of more information about the company. I want to show you our single product, what we have. This is the Dragon. And we built the Dragon especially for a town. There's a play each year. And this is the world's largest walking dragon. And this is also a part or in the Guinness Book of Records. I want to explain some data about this. This was the first run in 2015 out of the hall after the implementation. Just now it looks really better after 4 years additional development of the sensoric and all this stuff. And this dragon is 45 feet long, 25 feet tall. Weight is approximately 11 tons. Inside we have an engine, a diesel engine with 140 horsepower. We have also 20 gallons of stage blood there. In the end of the play, the dragon dies. And he has also to spread out the blood. And we have also 3 gallons of liquid gas inside that we can also spread out a 15 feet flame from his mouth. Yeah. And this dragon is completely developed by Zollner and also built there. All the mechanical parts, all the electronics, the software, everything is built by Zollner. And I think this is the best impression that you know what we can do for our customers. Yeah, I think it's the best thing to remember Zollner. Thank you.
Have fun.
Yeah. Yeah. Introduction?
Yeah, just a 5 minutes overview.
Yes, hello everyone. My name is Ruben Villarreal. I'm an advanced manufacturing engineer focused on the Industry 4.0 vector. Right, I'm the lead for the Americas region. I've been in Flex for 7 years. Half of it I've been working from Guadalajara in Mexico. The other half I've been working here. I transferred here to Milpitas. I'm part of I'm leading with a couple of colleagues the vector of Industry 4.0, right? And we focus. We know that Industry 4.0 is it's a very broad term. And what we do is our higher management decided to focus on 6 pillars, which are our key 6 pillars. I'm going to name them, and then from there we can go on. The first pillar we focus on is smart automation, right? And this is everything talking about collaborative robots, repurposable cells, smart machines, visual inspections, all these kinds of things. For smart automation, we had a spin-off company called Bright Machines. Maybe you guys are aware of it, but basically they're the ones that are managing these repurposable cells for us, and these all fall into this first pillar. The second pillar is called additive manufacturing. Additive manufacturing is everything related to 3D printing technologies. You know, we have a whole ecosystem across all our different sites. You know, top grade and end of the top-notch 3D printers, where we could actually, you know, print out jigs, fixtures, spare parts for the customers, for the products and all that stuff. The third pillar is machine-to-machine communication, and this is where we're falling under. We're able to see all the connected standards, and this is where we could see the IPC CFX, the Hermes standard. This is all the standards we're looking into. Being able to connect all the machines. We have a lot of test equipment, old machines around all our different sites, and we're trying to make them smart. We're trying to identify all these machine-to-machine protocols. And that's part of what our team is dedicated to. The next pillar is simulation visualization. We have a dedicated team to actually, you can simulate a whole production line, and before even placing them physically there, right? So whole dedicated team around the world that's focusing on using simulation as a service. I'm on the fifth one. The fifth one is business intelligence, which is everything about visual management tools, dashboards, real-time data, end-to-end supply chain visualization. We have also a dedicated team, right, across the different departments. And the last but not least is augmented reality. We're not focusing on the headsets because those are very, very expensive. And what we're using them is leveraging our phones, our smartphones, to actually come up with an app. Our internal IT came up with an app where you can stream and have your, connect to an SME on the other side of the world and be able to have remote assistance, be able to see work instructions through the app itself. So these are the 6 pillars that we are focusing on. And it's basically the key pillars and building blocks on how we are going to get to the factory of the future, right? So we have dedicated teams about this, and from there, I'm gonna probably play a video after, so you guys could see what we think the factory of the future, what our vision is for the factory of the future. Thank you.
Hi, I'm George Pang. I am VP Engineering at Tempo Automation. And Tempo does a lot of things, primarily with PCBA, with assembled printed circuit boards, electronics in general. However, I am primarily going to talk about software because my core focus and a core focus of Tempo is software and how we integrate with our factories and how we integrate with our data, our supply chain, our logistics, our shipping, how we place, everything we do in electronics. A core duty of Tempo is deep transparency into our manufacturing. So what we offer a lot of customers is a true understanding of what actually happens in our factory in every way and in every form. And a core duty of software is to pull together what you might consider to be sort of a chaotic firestorm of things that happen in factories, things that happen in electronics, and pull that all together into a cohesive thread, the digital thread that the founders of the company talk about, the digital thread that's on our website, to pull that information into an accessible form. Over time, our complexity has gone up over the years. We started out with startup level stuff, simple boards, few components, whatever. And over the years, we've worked towards higher and higher complexities, higher and higher placement counts, more and more complexity of programs that we work with our customers on. And as we go into that, we go into it knowing that we have to pool all this information together, because what our customers are asking us for is exceptional quality, exceptional speed, and exceptional visibility into what happened, obviously in many cases as they go to full production eventually, past the prototyping stage with Tempo. And so my teams primarily focus on 3 areas, like 3 core areas. We focus on pulling data out of our factory, extracting data from our machines, extracting data from our workers, having the course of their work be pulled together in a way that is better traditionally than a PLM or an ERP would actually be able to deliver for you and really deliver reward to our customers. Secondarily, we have a team which focuses on consuming the artifacts which our customers send us to build electronics. We receive CAD, we receive BOM, we receive a lot of preferences, we receive a lot of engineering change orders, and that I have a core team that addresses the fact that we need to take that and digest it, ingest it, and reassemble it in digital form in order to be able to provide visibility to the customer that we really are building what they want built, and that we really understand everything about it. And as they move through their program year after year after year, that we can capture all of that over time, and they can continue to capture every change that is made, every problem on the line, every problem they may run into on the line over the years. And then, of course, the last team, which builds our core applications, which are our front end, which is how we actually show customers and all of our internal users, all of our tools that are built on these data pipelines and these data streams. And I don't have a video to show, unfortunately, but that's a core description of Tempo, I suppose. Thanks.
Okay, hello? Okay. Maybe I should show the video now. I think for China, let me go ahead and show you, but basically, we have identified a couple of pilot sites around the world. We have different regions, right? I'm leading the Americas region. Someone else is leading, the Asia region and Europe region, right? So we've identified different, the sites that are most technological. And what we're doing today is educating the sites, because there's a lot of people. There's a lot of sites that are still in industry 1.5, right, or 2.0, and we want to understand and educate them how to get to industry 4.0. So as what we're trying to do first is identifying one site at least between the different regions, and from there gradually being able to install technologies, key technologies that are able to push us to the smart factory. So let me go ahead and show you the video. So to better illustrate what type of technology we're having. Okay, so here I'm just going to go ahead and narrate based on what we have here. There wasn't, when we started this vector a year and a half ago, there was nothing, that talked, we heard about Industry 4.0. I'm going to pause it quickly here. We heard about Industry 4.0, but it wasn't in our industry, right? So contract manufacturer didn't have, we tried looking at Google, in Google, and we didn't find anything about us that speak the same message or about our business. So our team decided to put together what we think our contract manufacturer would look like. Right, just maybe it won't look like this, but this is an estimate of what we envision it's going to look like, right? So as you see on the top right here, we have the 6 different pillars, right? I mentioned you earlier, and of course they're going to be popping in depending on what is going on, right? Robotics, additive manufacturing, augmented reality, and these pillars represent the key technologies. As we know. Flex is a worldwide company. We have 100+ sites, 200,000 employees, so we're trying to standardize doing this. Of course, the first thing here is machine-to-machine communication, our SMT lines. This is why we're here today. We have automated retrieval storage systems at the beginning. We have AMRs, right, automated mobile robots, right? We have our SMT, all our equipment we said today, right? We have machine-to-machine communication standards, connected to the cloud, and maybe our CFX. We're looking into all these different technologies to actually implement to our SMT line. Luckily, our SMT line is mostly automated. We just need to connect each of them as what we were talking about most of the people today. We also have our automated cells, right? Flex robotic cells, bright cells it's called. They're also connected to the cloud. We have collaborative robots as a vision to actually work alongside operators, maybe in a sub-assembly and passing it along. Maybe this guy needs some remote assistance, right? Site collaboration, right? You could see here from one site to another, he's contacting someone from another site. We're leveraging our ecosystem of 3D printers. You see this guy also being able to print parts of the product itself. and automated visual inspections for final assembly, for quality defects, cosmetic issues, all these things at the end of the line before packaging. Automated packaging, of course, and of course we have our AMRs, right, that go to a truck and sent to the customer, right? So, of course, all of these things are are connected to each other, and you could see there's a digital twin, right? Before you even set this line, you're able to simulate this whole line together. This is what we see on this side, the bottom side of the screen, right? So you're able to simulate the whole line before and be able to test out different problems ahead of time and all that stuff. And this is our vision of what we think the factory of the future would look like, right? So before I know we're far away from this, but the first step we're doing is actually, as I said, see how each of the sites are, educate them, and be able to understand the gap, right? Maybe they're in 1.0, maybe they're in 2.0, and then understand what we need to get there, right? Introducing new technologies like this, new technologies like IPC, CFX, the Hermes standard, all these technologies, new cobots that work with very easy to deploy, plug and play sensors, all these things we have identified, and we want to push them gradually to get there. So that's what we're pushing. We think that if one site, is set as an example, we could easily duplicate this site across organically, right? To the sites that are near, for example, one in China, if it's near it, it's going to organically adopt these new technologies too. That's how we're facing it. This is actually a good question. It is hard to say. I think it relies a lot on of course, the first thing is education. It could be 3 years, it could be 1 year, it depends on, it could be customer driven, it could be, but the only thing I could say is we're going towards that direction. I mean, it's hard to say an exact timeline, but yeah, for 2025, I think I'm getting ahead of myself, but maybe we already have, I don't know, 10 to 15 sites already connected and smart connectors within Flex. This is what I'm saying, because we could see all the different technologies we saw today that are already here, and in 5 years, if we could have maybe in 3 years we could have one already set as an example, and from there just duplicating these connected sites. Yeah, so one of our guinea pig sites is Milpitas here. This is what we're testing a lot of the different technologies out there, because we have a lab here in Milpitas, so the best site to do tests and POCs and all that stuff is here right next to our site, right? So we have Milpitas as one, we have Guadalajara, Mexico as another one, which is they have good infrastructure and they have smart people there too, and a couple of other sites that we've identified too. But first we need to begin with one. Milpitas, I would say, is the first one.
This is a good question. We talked also about it maybe 10 years ago, what we want to do in the future, and also what is our target for the future, and what has happened in the future to our company. And we decided, I think, the future is a software design production. Is this what we have in the future, and how we can achieve this goal? And this was a first question, what we did what we had in Zand in Germany in our headquarters. And then we decided, okay, the first step is we have to create data. All the software which we want to use needs data to get data out of them, and how it's possible to create the data. As first is we need accurate data. Accurate data is the biggest thing ever. If the data are not correct, we cannot use them with the software. The next thing is to get the data accurate, we have to standardize all the production, all the stuff what we need. If it's possible to eliminate the human creativity from the production, I think that's the biggest point. And we started with this approximately 15 years, 20 years ago, approximately. And we improved this a lot over the years just now. And we have over the world all the same machines. That means We are really standardized this, and we have to develop only this in one time. And most of the time, this is driven by customers. This is how we organize this, and we not have really a site which develop all this stuff. We have on different sizes. The customer comes to us and wants something, and we have to develop this. And most of the times, it develops this directly with our headquarter in Germany together. And we have the same machines. It's easy to transfer all the knowledge over the world. And this is what we do. We not really have one site which develops all this stuff. We have it over the world, and we can do that over the world.
Yeah, I guess for Tempo, we only have one facility, so obviously we would presumably use that as our test facility. I think that one thing I would mention, though, of course, is that like our core concentration is similar in that first and foremost, we have to know the truth. Like we have to know the reality first, entirely apart from that. And then with that reality, we can use interfaces efficiently, like Connect Factory 4.0 and so forth, to efficiently deliver like what our customers need. But we have to write down the truth first. So part of our core duty in our factory is writing down that truth. Like if we receive consigned fabs, to write down the truth of those fabs and to know that they are similar to CAD data for real, not just to make guesses. If we do paste on something, to write down the truth of the physical paste that we put down and compare that with the paste layers and be able to deal with that in CAD. And how that flows back to people, whether it's via Connected Factory or whatever, or IPC, is interesting. So a lot of our stuff now is a bit proprietary, but intended to feed into non-proprietary systems. For example, when we consume IPC 2581, we build it into proprietary formats, which we're migrating over time. But as a great example, some of our largest IPC 2581 files are 1.7 gigabytes or so of XML. And when you try to load that into memory as a software engineer, you find 16 gigabytes of memory using a typical load. And if I take the core data that is actually within that CAD and within the layers of the CAD, I can actually write it down in about 29 megabytes of data. That's much faster to access, better indexed, easier to work with. And no one else might want to directly work with that, but we may be able to provide it outwards via interfaces of various kinds. And those would all be within our single core facility at the moment, of course. I see that our factory has traceability down to the pin level on every component. We have traceability down to every component. And we also have we have capability for you to see everything that happened in every single way. Like in that if a pick and place machine failed to place a component on this particular board of this particular component and then place successfully a little bit later, that we have a clear and clean interface for you to see that and visualize that through our own systems. But also, hopefully, we're pushing them out through standards-based systems so that you can, in fact, see that and use that and understand that and roll that back into your own process effectively.
Maybe I still explain this from our side. The biggest thing is data. And if you have accurate data from the past stored, then you can develop maybe each software. Then you're not thinking about how it looks like a reflow temperature protocol. The software will create this. Or we also discussed today about a solder paste printing machine. Yeah, we want to create a program, a raw program, and then later on we improve the program. But just now we're not thinking about this. The program will be created from the first step on in the right way. And this is, yeah. Yes, yeah. But the basic is the data and the accuracy of the data. And if you have it, then what I can see in 5-6 years, maybe the production will be driven by software, yeah.
Yeah, for us, I think the main challenges to get there is standardization from our side, because we have a lot of different sites. And this is something we are looking into being able to work with the sites to, educating them first and everything like that. I think another one would be we have legacy products. For example, our MES system is homegrown, right? So this is one of the big products we have across. I mean, it's called FlexFlow, and we use it. It's very flexible and everything, but this is getting rid of legacy products like this. I think our way to, it's very challenging, but what we're trying to do is building off of it, right? Being able to add services like machine learning to this that could basically attach to our MES system, right? So we have a couple of challenges, but we know how to address them. I think another part of it is we're siloed, right? Flex right now is siloed in different sites, and everyone is currently they also duplicate efforts or initiatives and stuff like that. A lot of people are working on the same things, right? So I think it's a team effort where it's multidisciplinary. I mean, different teams, and this is something we're working on today, putting together the right people from the right departments to actually organize ourselves and be able to standardize these solutions, right? So I think we know these challenges, and we know what are the stepping stones to actually overcome this. We are working both internal solutions and third-party customers to actually be able to, as we said, connect all the machines together, be able to find a standard way of doing it, being able to, it's actually surprising because we see all new players in town that, they're predominantly software companies, big software companies that now manufacturing is cool today, right? So they want to go into the manufacturing industry and with, applying machine learning into data, all these things, right? So I think one of the challenges, as I said, is the first thing we need to do is connect all our factories, connect all our machines together. Once we have a whole backbone of data, as my colleagues were also saying, from there we could leverage the machine learning and the algorithms and all this from these key players too. So we're partnering with key suppliers and colleagues. That's part of what our team is doing, right? So we identify and evaluate the different solutions out there and best practices even between the different sites, because sometimes there's a site that already discovered what's the best practice for something, and on the other side of the world they're doing the same thing or having a problem with the same thing, but they don't know. So our job is to actually connect the dots, right? Being able to find a solution somewhere and it's like, okay, we know the right guys. Here you go. This is a solution. So we're putting up together best practices to solve this issue, right? So that's how we're trying to push for the factory of the future.
Yeah, I guess from our perspective, I have an unusual perspective, by the way, because my background is traditionally software. The first time I worked in a factory was for an old company. It was while I was still in college, really. I worked for Sperry Marine over on the East Coast. But anyway, I haven't worked back in manufacturing until now, truly. And it's very interesting to young software engineers these days to actually work on manufacturing, to touch the tangible world again. But we view our problems through a bit of a different lens. So the first thing you consider as an engineer in general, but one thing which is hard to get to sometimes when you're working in heavier weight things than software, is state the problem. Like, what is the problem? It is not that you did not implement an ERP. It is not that you did not do so-and-so necessarily, but state the problem correctly and make the attempt at least to state it in a way that even though you're lifting heavier weight things, because you're doing manufacturing, that you try to head towards a better goal, right? And so that's number one for us. State the problem correctly, because we're a small company. We don't have that many software engineers compared to Google or Facebook or wherever else, and we never will. But we have to face the right problem. If we face the wrong problem entirely, then of course we won't get there. We won't be able to build that connected factory. The second problem is we are a startup inherently, and so we're solving that traditional startup problem that you got to fly the plane while you're building it, right? So you're flying the plane and you're building it, and if you're Facebook, then it's okay because you could break the feed. You can break in images. You can break whatever you want. It doesn't really matter. It's all fake news anyway, right? But if you're us, you can't do that. We guarantee quality to our customers. So we have to build the plane, fly it, and fly it perfectly at the same time. And that's very important because no one wants faulty electronics, right? So we have to do all of those things together and do them really well. And as they've mentioned, and as we've mentioned, data is super hyper integral to that. Writing down the right data, getting the right data. And my belief now is one of our core problems surrounds the general, I don't know how to state the problem correctly, but engineering change orders and program management for us are hyper important because we've gone in a super complex direction with a lot of our customers. Being able to handle that well is super important because if you do not, you leave a huge cliff overhang where you're like, oh shit, like I did not actually write down the correct full information for this. So how do we deal with this in software traditionally? We use dependency resolution systems such that I change a file, my system rebuilds, my tests all run, I am back up and running, and I deploy effectively. And what is the equivalent of that for manufacturing? Of being able to write down the truth, to break the information deficit gap as rapidly as possible so you can write it all down, get it all down, such that the next engineering change order comes in and you again realize that, oh, okay, again, this is only changing 7% of the picture or whatever. And so that is how we think about those two core areas, I think.
This is nearly everything. You have right. The first thing is the data from the customer. If we get the right data about the product, what we have to build, then we are in a good shape, and then I think we can go forward. The second thing is you need also all the data from our suppliers. The material height, the weight, whatever, chemical data, whatever. And this you have to put together to create a new product. And to do so, you need the data from the production. That's we're talking about maybe the EDI connection to our customer. This is maybe easy. You have 10 or 20 or 50 customers. But if you're talking about suppliers, then you have 200, 300, 400. If these are big players, then maybe it's easy to get the data also via EDI. But if they are not, then you have a huge problem to get the right data to your system. Yeah, that's a challenge. Yeah.
I think we need, or we would love it the most probably, because we do move really fast, and we would love super deep integration from any equipment supplier. I would love better visibility. I know people are using old FoxPro databases. I know people are using DBase databases for some of their systems now. That's fine. We know why that happens, but we need more insight into how it actually works. And some great openness into like, well, we need to do some things. Like, I want to move data around between machines. If I want to be able to say, I'm going to build a program automatically that will execute on both pick and place and AOI at the same time, and I have to get the packages and the parts into both machines and their libraries at the same time, how do I do that reliably? Like Europlacer, for example, that we do use, we have trouble syncing the database. We just have a bunch of parts definitions and package definitions to get in there. And there's no clear, consistent API for us to push that data in so the machine simply has it. So we find workarounds. We find a way to do it. But the more equipment suppliers are willing to work with us, no matter what the equipment supplier is on the line, we would love to just be able to like have a good back and forth of like, I know you don't want us to touch the motion control. I know you don't want us to touch the real-time computers that actually drive the machinery in some cases, but we would love to like somehow send it in through the front end essentially to be like, hey, we need to adjust some packages, or we need to synchronize, or we need to do whatever it is we need to do.
For us, I think what we need to get there is I think it's three things. From the vendor supply, I mean, of course, the industry standards. We're looking for the vendors to follow, multiple or a couple of industry standards, and that way as long as they offer these features and can tie with the different equipments we have, because we have a lot of different throughout the regions. Everyone prefers different suppliers, right? So as long as they're able to speak to each other, I think we're good, right? So. I think the three main challenges is basically define the standards. The vendors would follow these industry standards, and we could make use out of it and grab the data. And from our side is a lot of education internally in Flex, because everyone, as they were saying before, they ask for the ROI immediately, right? But But they have to understand that we're also, in order to push to the Industry 4.0, we also need to, it's innovation and it'll soon come, right? Once we have all the data and we're able to leverage these technologies, right? So that's what we think we need from your side.
Maybe I can only agree what you explained here. Yeah. Only what I want to do or to add to this, if we look forward and we want to work together with a new manufacturer of machines, something like this, then we're talking about what you want to do in the future. What is your vision? This is also very important for us to know it, that what they are thinking about the market and the future of this machine, about these processes, what they have to realize to know that we want to go with them. And this is really important for us. We have also a vision for us, and this should be matched. If this is not the way, then we cannot come together. Yeah, thank you.
I just wanted to add also on that side, we're talking about the digital twin, right? And we're trying to use simulation as a service even before we place the production lines, right? And we've noticed that a couple of suppliers or vendors are, today they just released the CAD models of the equipment and everything. But there's a lot of push on some of them that we've seen that they want to add like a digital, what happens if you add a digital twin format of your product itself, right? That could interact with the physics of the machine, and it's able to calculate, the data you're also extracting, you could also simulate that data, and being able to simulate like the digital thread we've all been talking about, right? Maybe you release a CAD model plus the physics in it, right? And that's what we call like a digital twin format. Who knows, right? This is what we're talking about. 2025, maybe the vendors start releasing digital formats. We've talked to a couple of German suppliers that they're already thinking about that. So just wanted to mention that. I think the guys who are leading this topic is Siemens right now, and I think they're also pushing for that format itself.
Yeah, I think for us, I think what you alluded to is the digital twin. What is it a digital twin of, right? What are you modeling? Like, what are you simulating? Like, what are you touching? For us, we're a little more specific, obviously, since we simply do PCBA as our core business right now. Our digital twins, obviously, PCBA and the PCBA manufacturing process. And so for us, in this focused way, it is like, well, let's capture everything that happened, could happen, will happen, and might happen, effectively at every point in the line down to the pin. Or down to the whatever. And so what we believe we might end up doing is building small data lakes that our customers may be able to use directly through our interfaces, but may also be, we can just simply give them the data lake and they can take it, walk away with it, this 300 megabyte file or whatever that contains every superposition of everything of all those things. What could happen, what might happen, what will happen, what you need to worry about, like what did happen, and so forth. And also all of your own information, the things you told us about what needed to be built also go into that. And all of that together gives you a cohesive whole, a weird quantum superposition Brownian particle of like everything that is about that program or that build of that program or that batch or that job or whatever. That's what it is to us anyway, since we're more focused. Again, it's probably easier for me since we're focused. We have a smaller number of roles probably than everyone else, but we see it as like, first of all, empowerment. Obviously, like we see that our roles will change somewhat. Like maybe some roles will go away, but we see it as empowerment. Like if so, our best AOI operator is this guy Garvin, and Garvin's amazing. He can do anything in QA, but he does AOI and X-ray and astonishingly, and does really well by our customers. And so Garvin will probably continue applying his vast expertise on the things he understands that I don't understand super well in our lines. And we will empower him to not only run more AOI and X-ray in his super great way than ever before, but also deliver more contribution to the process than ever before because that stuff will get captured magically for him. And that's what we do in software. We don't like to say we make magic, but we do have to adjust process in factories, but hopefully not in ways that is destroying someone's life, that is destroying their role, destroying their skills or expertise, is simply multiplying their power. Because these guys are highly skilled and highly trained. They know what they're looking at and what they're looking for. You can't throw that away. And then so that is our belief. Like if I can multiply Garvin by 6 and give him 2 times more domain coverage of things that are super useful to our customers, that just makes Garvin like really happy because he feels that much more productive and useful. But it also just multiplies his value in general in the workforce and multiplies our value to our customers.
Yeah, well, I think same thing. Well, now it's a trend, right? Data is, someone was saying in the morning, data is more valuable than oil today, right? It's very valuable. So I think it's going to happen very similar to someone who used to study electronics and mechanical. They were both separate things to study, right? So they merge into a mechatronics degree, right? So I think this is something that's going to start merging together. Certain disciplines will start to merge and going to the software side, right? And of course, I think the people who are working, already in the machines and everything will also be skilled and trained to these to adopt these new trends and technologies. That's what I think.
Should I explain this in order? I think we have 3 things. One is a standardization, what we need in the future, especially to create the right data in the right way. The other one is our flexibility, what we need for our production, and the other one is a creativity. But if I look at 20 years ago, I think the creativity and the flexibility was a huge thing for us. And just now it's moved more to standardization, flexibility if needed only, and use the creativity to develop the standardization. This is a really important thing. If you have a really robust standard process, this includes also deviation from the standard. And for this, you need creativity to really develop this process. And this may be changed for the future, and we have to look at it really. Yeah.
Well, you said how far are we to get to lights out factory? I think I answered this question. It's very similar to, we don't really know, but we're tending to go there. I think another of the challenges we have as a contract manufacturer is that we don't own our product, right? The product is always changing. Every 6 months there's a new model. Every 6 months there's something new. So it's difficult to say, to be. I mean, maybe from the warehouse standpoint, we could do something like what Amazon is doing from the warehouse side. But I think for now, we're just pushing towards it and see how it goes. Maybe there's a technology that allows us to go there much quicker, right?
Yeah, I mean, I think as a software engineer, again, I return to the traditional state the problem. Is the problem really having a lights out factory? Or is it general efficiency, throughput, ability to handle load, ability to handle change, ability to scale, things like that? Those to me are the problems, because we're high mix and we are really high mix. And when we look at the scale of problems we face as like with our customers, it doesn't make sense. Like the obvious way to go to lights out is literally to just cut down our mix and be like, no, we're not going to take weird work. We won't do it. We're only going to do stuff that's exactly this way, exactly laid out this way. That's not what we do, and our customers value what we do. So we don't treat it as a direct target, I suppose. We might head that direction by virtue of the fact that like we will stop doing certain things that are just silly for people to do. Like I watched some of our process teams assessing a particularly complex BOM last week for a couple hours, on and off. They dragged me in 4 or 5 times to help them with like software manipulations. And eventually I spent 4 hours one night and I wrote a BOM diffing tool for them that was custom to sort of the thing they were explicitly trying to do, that eliminates this weird meeting they had to have 4 times a week for this one particular odd issue. And that's an example of removal of a thing that could theoretically lead towards lights out, but we're not, again, it's not targeting that. From our perspective, or more from your perspective, like Okay. Sure. From my perspective, this is not our secret sauce. Like how we actually placed that order, how we actually, like which exact components we used, how we set up the epoxy curing process, whatever it is that we did is not, that's not the secret sauce of that we shouldn't be sharing with our customers. Number one, there's actually such high complexity in there. Most of our customers wouldn't want to do that anyway. To save their lives, because they're like, oh God, like I didn't realize you had to do so much in actuality to build this board, or to get this fab, or to deal with this crazy conformal coat company or whatever. And so we don't worry about that part of it at all. We actually suspect that we may actually open source even more so some of the things that we don't really have to open source to make, for example, our data more accessible to our customers. You know, in cases, we realize that our customers typically don't have tons of software engineers either, but we want to make our data more accessible as much as possible, no matter what, in a way, because it's really their data. It's not our data. It's for their product. It's a capture of their product, and they're not going to take that and run off and try to do something with themselves, probably, or with some other vendor. In our case, other than the fact that we typically don't do full production. So so they should take the learnings from that and move on to full production correctly, because that gives them value and that raises our value to our customers. Because if we tell you, if we surface an issue to you that you're going to run into a production, that was what you wanted to know, right?
Yes, this is also what we did in the past and what we also did just now. We share all the data about customer products just in time. They can get the data. I think we have a delay of 2 hours approximately, and especially quality data. That's the first thing the customer interested in, and this we do it just in time. That's a normal doing in our factory.
Yeah, I guess for us, we do use the cloud. We use GovCloud on AWS, which is, if you use it correctly and not willfully wrong, then you will effectively be ITAR compliant, as long as the things you build are also ITAR compliant and things you actually do with it are also ITAR compliant. I believe in 2017, ITAR regulations changed a little bit to enhance cloud use a bit. So it's no longer illegal to have encrypted ITAR data out of the country, which is kind of helpful because, you know, data moves around on the internet, and if it's encrypted sufficiently, it should be okay if it briefly crosses the border and then comes back or something like that. And so that's a very nice change. I need to read up on the rest of the changes in 17, but we are not threatened by it in a way because we have just always used it. We do also do stuff in our factory. Like we run the same software in our factory on physical servers and VMs in our factories that we do in the cloud as well, and we deploy the same way. We have really heavy testing of our software, and then so one of the benefits that we have is that we actually have this thing called continuous deployment, which means that if a software engineer makes a change to a tool set and wants to deploy it, and they've gotten all the appropriate review, all the tests are running correctly, then they can actually deploy it on the fly instantly, and it will go out both to the cloud and to our factory instantly. So we could at times deploy up to 7 times a day our tool sets to our factory and to our users and really to our customers as well. So we aren't threatened by it. There's of course the other side of it, which is when someone else is considering you as part of the cloud and is thinking about you as cloud. You know, because similar to digital twin, it's like, what exactly is the digital twin? What exactly is the component of the cloud? And then so you kind of have to think about that yourself. One of the core systems we've decided we probably just need to give up and build our own because there just aren't super awesome solutions to do certain things is file transfer and file sharing, because it's so prevalent that we have to do a lot of file sharing and file transfer, and we probably we will use some third-party tools to do that in a lot of cases, but we also need some internal custom things that are like, let's just do it ourselves because it's so crucial to our business as to how we do that, and that is part of the digital lake that we want to build eventually anyway. So shouldn't we just own that and control that carefully to make sure that things don't go wrong?
Yeah, for us, there's 2 sides of the cloud, I guess. We are looking forward to use the advantages of the cloud. It all depends on from the customer side, right? There's customers that are very sensitive for their information to be in the cloud, and sometimes they want to use a fog approach, which is basically a local server in the site itself. That's where they store their information. Or even we also could get an edge device, right, that's doing the processing on the cloud, right? So that's from the solutions perspective, right? So sometimes we're looking right now into a couple of solutions that, you know, all the processing power is done on the cloud, and it's able to take images and stuff like that and store it in the cloud too. So I think we are leveraging all the 6 pillars I mentioned. Those will generate a tremendous amount of data, right? So we need to store that data somewhere and process that data somewhere. So we are looking into cloud solutions. There's an IT team that's also, they have the relationship with each of the cloud vendors, and their specific security. Also, there's a security team that's actually evaluating whatever is going into these cloud services. But it ultimately goes into what the customer wants. That's from our side.
Yeah, we just now not connected to a cloud, but we are talking about it, and it is a must in the future. This is what we're thinking about. What we not want to have in the cloud is customer data, especially product data. What we have in the cloud, and this is a must in the future, especially production data. But this is anonymous data, especially let's talking about AOI pictures from a 05, 08 capacitor or resistor. It doesn't matter of which board it is, it looks every time the same. And especially if you want to create AI functionalities over the world, you know, if you have more data, you have a better result. And this is a must. You have to do it with the cloud.
Yeah, I guess maybe it's worth my talking a little bit about the concepts that should alleviate your fear of the cloud to some degree. And a lot of this is going to have to do with your own internal IT staff and your own IS staff and software staff as to whether or not, like, again, as I mentioned, if you willfully do things wrong with any tool, be it in your factory, be it an Ethernet switch, be it a firewall, be it a cloud server, you will violate something that you don't want to violate, like ITAR or customer IP concerns in general. So the question is really being as careful and as deliberate with the cloud as you would be with your internal systems, because they are your internal systems. And if you look at GovCloud in general, for example, on AWS or Azure's version, what you'll see is systems that in some ways are actually safer than your internal systems. Like, what exactly happens to a hard drive of some DFM guy that their hard drive died? Does the IT team throw it away? Do they magnetically destroy it? Do they physically disassemble it? Do they burn it? Do they melt it? If you go to GovCloud and you have a similar thing in GovCloud that is potentially something you want to protect, AWS issues hard guarantees that they will, in fact, correctly overwrite all non-volatile storage of that data, and that it will be encrypted always at rest. It will be encrypted always in transit until it hits the edge of the internet, at which point you've deliberately done something to put it on the internet, like an image or something, if it's a safe image to put on the internet, or whatever it is that you're trying to do. And then so in a lot of ways, GovCloud is safer than your internal systems, because you know, being that Amazon themselves does a ton of work with the government, that they've actually, at the base level, they have already honored a lot of the constraints that you should be worried about, which are actually hard for you to address as an individual, relatively small company compared to Amazon. It's hard to guarantee that you're going to destroy the spindles of your hard drive. It's hard to guarantee, even having destroyed them, that you've electron erased every platter of every disk. And I can recover data from any of those. If you give me a platter, I will recover data from it. Even if you magnetically wiped it with one of those old Radio Shack degaussers, I will probably still recover data from it.
I guess from our side, the biggest frustration is from our customers is usually some products are not designed to be automated or manufactured. I used to belong to the automation team internally in Flex, and we've always came across a lot of products that were not meant to be automated. So we had to find a way around it or create new patented, tools to actually be able to automate the thing, right? I remember we created it was a fan assembly, right? And you had a duct and had a large wire, right? And for wire, if you want to automate something that has a wire, it's almost impossible to do that, right? So and it had a little sticker that went around it, right? So, and these fans would go into server boards, right? At that point, the customer would say, I mean, our customer was Flex, right? Because we were part of the automation team and we supported our Flex sites. And they just gave us the product. And it's like, okay, it's this product. It has this sticker around it and it has a cable. Find a way to automate it, right? So what we did was we automated the whole thing, but we had to find new creative solutions. We partnered with other people and everything. And at the end of the project, we noticed, we figured out that this thing, the sticker, was only a handle for the operator to actually place it correctly into the server board, right? So it's like we automated the whole thing just for, and if we would have known it was just for that, we didn't need to automate that, right? So there's a lot of frustrations that there's no communication between the customers and ourselves, and I think always having maybe the design for manufacturing, the automation, even simulation, right, tied in, I think we could avoid all these frustrations. I think that's basically it.
Yeah, I think from our perspective, we've been working a lot on CAD data ingestion and ingestion of the core artifacts that our customers have. And so one of the things that's obvious is we will eventually be providing useful feedback in effectively digital form, which is of changes they may want to make, or things that our fabs may want to make, or whatever it is that's necessary to make something manufacturable, like in a DFM process or so forth. And we need some way of feeding that directly back to the customer in a clear way, whether it is with Factory 4.0 or whatever, that can get ingested effectively back into the customer process efficiently, so that instead of us continuously correcting that one problem over and over again, that it goes back into the original core CAD design or whatever it is that the customer has in an efficient way. And I think the customers have to be accepting of the fact that there may be some process change involved in their own R&D process of building these products in order to accomplish this. And it will clean up everyone's lives, including their own, because if you know you don't want to build that fab that way, then it's probably better if you get that change back into your CAD to begin with, instead of sending it on every time.
Thank you, I agree.
Yeah, exactly. From our perspective, we hope someday to give you an actual digital form of it that's easy to ingest. But it's a tricky problem because there's so many CAD vendors and so many ways that you might represent your data. So I can't say it's a solved problem in my mind, even if I did infinite amounts of work on it. But at the very least, to get some data back in a clean way, like if we know in some case that the fab is fixing a pad that's actually wrong in the CAD, having that change translated back in, like it can be done by word of mouth, like we can tell you and you can change it in your CAD. But obviously in the super ideal case, we could feed it back to you in some way that you see it as a change, a delta change that you can simply approve. So I kind of suspect that the thing needed here is actually a bit of more standard, maybe, or maybe I'm just unaware of some good standard for this, to have that information flow back in a CAD agnostic way that can be accepted by any CAD.
We started approximately 10 years ago with a ZVEI interconnection, what we developed in Germany, and all the machines are connected with this interface. But what I see just now also in the market, especially also German manufacturers of machines, they all switched also to CFX, yes. Yeah.
Yes, I agree. First step is standardization to actually, get there and do everything. And we do have, CFX as one of the good standard to actually communicate, to do all this standardized, from the SMT side. We have I'm saying this because, and maybe I'm wrong, right? But I come from the automation world, and I remember they came up with a standard called OPC-UA, right? Where we're trying to find out, because we don't know, we have the SMT side, we have the back-end side, we have high reliability solutions, other businesses that we also need to find other standards to communicate and talk to each other, right? So, but definitely we're looking into, you know, working with our IT teams on educating themselves because we need to create the solutions within Flex.
Yeah, I mean, we do expect to head towards CFX in general, but admittedly, we have a lot of proprietary tool sets and systems that we may open up ourselves that we probably will use because we have to visit certain purposes directly. Like we need that data transparency to our customers, and if we notice that we can't do something via IPC, via CFX, via whatever, we just won't do it that way initially because we're just trying to head towards solutions for problems. And but yes, in general, we will probably be heading towards CFX.